Hi everyone, and welcome to this lesson 31.3, graphing a quadratic function. In order to graph a quadratic function, we need to know three things: the axis of symmetry, the vertex, and the x-intercepts. Let's start by finding the axis of symmetry. So step 1, find the axis of symmetry using the equation x equals negative b over 2a. So in order to do this, we need to label our a, b, and c values. A is 1 because there's no number in front of x squared, so it's an imaginary 1. B is negative 2 because there is a negative 2 in front of x. And c is negative 3. So now let's go ahead and plug in our b and a values. I have x equals negative b, which is negative 2. So please be careful. One negative is part of the equation, and the other comes from my b value being negative. Divided by 2 times a, which is 1. When there are two negatives next to each other, the value turns positive, and 2 times 1 is 2. 2 divided by 2 is 1, and so my axis of symmetry is the line x equals 1. This also means that my vertex has the x coordinate of 1, and we need to find the y value. And we do this by plugging in this x value into our equation. We are going to find the vertex by plugging in the x value, because I know that the vertex shares its x-coordinate with the axis of symmetry, and in order to get the y value, I'm going to plug in the x value that I know. So 1 squared minus 2 times 1 minus 3. If you plug this into your calculator, you should get negative 4, which tells me that my vertex is the point 1, negative 4. The last thing I need to find in order to graph my quadratic function are the x-intercepts. And if you remember, we do this by factoring and setting our factors equal to 0. So I'm going to rewrite my quadratic function down below, x squared minus 2x minus 3. And I want you all to get into the habit of looking for a GCF first, before you do anything else. Looking at this quadratic function, I do not see a GCF bigger than 1, so I'm going to proceed with the magic x. Negative 3 goes on top, and negative 2 goes on the bottom. The only two numbers that multiply to 3 are 3 and 1, and in order for 3 and 1 to add to a negative 2, I need to make the 3 negative. So my factored form will be x minus 3 and x plus 1. In order to find my x-intercepts, I need to set each of these factors equal to 0 and solve. The opposite of subtracting 3 is adding 3. So positive 3 is one of my x-intercepts. And the opposite of adding 1 is subtracting 1. So x equals negative 1 is my other x-intercept. And now that I have these three pieces of information, I am ready to graph my quadratic. The first thing we found was the axis of symmetry, the line x equals 1. So I'm going to draw a vertical line through 1 on the x-axis. Then we found that our vertex is the point 1, negative 4. And then lastly, we found our x-intercepts are at negative 1 and positive 3. And this helps us draw our parabola. And we know that our parabola is a smiley face, because our a value was positive. So those are the 3 steps to graphing a quadratic function: finding the axis of symmetry, then finding the vertex, and lastly finding the x-intercepts. So let's try this again. I'm going to start by labeling my a, b, and c values. A is 1 because there's no number in front of x squared. B is 4, and c is -5. My first step is to find the axis of symmetry using -b over 2a. Now that I have my a, b, and c values, I can plug these in. So -4 divided by 2 times a, which is 1. 2 times 1 is 2. And -4 divided by 2 is -2. So my axis of symmetry is the line x equals -2. So I can go ahead and graph this axis of symmetry. Because my axis of symmetry is the line x equals -2, I know that the x-coordinate of my vertex is -2. And in order to find the y-coordinate, I'm going to plug in -2 for x. So -2 squared plus 4 times -2 minus 5. Plugging this in, I get -9. So the point -2, -9 is my vertex. And lastly, I need to find the x-intercepts by factoring. So I start by looking for a GCF. Looking at this quadratic function, I don't see a GCF bigger than 1, so I'm going to proceed with the magic x. -5 goes on top and +4 goes on the bottom. The only 2 numbers that multiply to 5 are 5 and 1. And in order for these to add to a +4, I'm going to make the 1 negative. So my factored form will be x plus 5 and x minus 1. And then to find my x-intercepts, I set each of these factors equal to 0. The opposite of adding 5 is subtracting 5. So -5 is one of my x-intercepts. And then the opposite of subtracting 1 is adding 1. So +1 is my other x-intercept. And then I'm able to graph my parabola. And once again, this is a smiley face because my a value was positive. Let's end the video by trying one more. I always start with labeling my a, b, and c values. If you notice, I don't have a constant term, which means my c value is 0. So a is -1, because notice how there's a negative in front of the x squared. B is 4, and c is 0. My equation for the axis of symmetry is -b over 2a. So plugging in my values, I have -4 divided by 2 times -1. 2 times -1 is -2, and -4 divided by -2 will give me a +2. So x equals 2 is my axis of symmetry, which means the x-coordinate of my vertex is 2. And in order to find my y-coordinate, I'm going to plug in this x value. When I plug this into my calculator, I get +4. So the point 24 is my vertex. And then I need to factor my function to find my x-intercepts. We always start by looking for a GCF, and it looks like both of my terms have an x in common. So I'm going to divide by x. This will leave me with -x plus 4, since these x's will cancel out. And don't forget that you need to write the GCF on the outside whenever you divide by a greatest common factor. And then I'm still going to set each of my factors equal to 0. So I have x equals 0 and -x plus 4 equals 0. X equals 0 is already solved. Notice how x is by itself, which means that 0 is my first x-intercept. And for the second equation, the opposite of adding 4 is subtracting 4. So I'll be left with negative x equals negative 4. But I can't have negative x, so I'm going to divide by a negative 1 to both sides, which will give me that positive x equals positive 4. And that is my other x-intercept. And this gives me an upside down parabola. And that is because if you look, my a value was negative. And whenever my a value is negative, I have a frowny face. So whenever you're looking to graph a quadratic function, you need to find three things: the axis of symmetry, the vertex, and the x-intercepts. Please let me know if you have any questions, and I will see you in class.